and thanks for joining me, and welcome to part 4 of the Wimshurst build. Well, last time we got the drive system installed, and now we're going to install neutralizers, collectors, and the electrodes, and make some sparks. I'm really optimistic about this. We got quite a bit to do on this episode, so I better get started. Okay, this right here is a neutralizer, and I'm not exactly sure why it's needed or what it does. I do know that it neutralizes the charge across the disk, and it won't work without it. And the position controls amperage and voltage. There's an optimum position. It's got little brushes on it that contact the disk and contact these sectors and neutralize the charge. Anyway, we're going to change the electrode design on this one. Let me back the camera up. This machine here, I made it with the electrodes in front of the disk. Well, this machine that we're building now, I'm going to make the electrodes upright. They're a little bit easier to make. The machine's a little more compact depth-wise. Makes it easier to sit on a table. You don't have to worry about that additional depth in the back. But the neutralizers will get in the way of the electrodes that run an arc like that. They'll hit that. So I got to redesign these neutralizer bars. And I think they'll be a little bit easier to make. So I'll show you what I'm going to do on that. Okay, the neutralizer bar attaches to that bolt right there. And to avoid that interference that I was talking about, I'm going to bend some wire like that, some brass wire. And this is going to be right there, and that'll go through it, and there'll be a little set screw in that. Kind of hard to picture, but it'll be like that. Anyway, you'll see what I mean when I get it built. You can make a neutralizer out of anything. It could be an aluminum bar, it could be anything. Anything that conducts. And unlike the rest of the machine, it's really not subject to discharge. If something's got a sharp corner, you're not going to lose a charge. So this shouldn't be anything real complicated. It's just some kind of conductor between the two disk halves. So I'm going to make this bar here. I'm going to make it 6 inches. Okay, those are 1/8 inch, and the center hole will need to be slightly over 3/16. I don't know if I need to go to the next size. Probably so. 13/64. Okay, here's the basic idea. Contacts like that. I'll put a brass ball on there. They're pretty cheap when they're real small. And I got to put a set screw right there and on the other end too. When you're using a tap this small, having it guided like this really ensures that you don't break a tap. These neutralizers will sit in here like this. And they may end up being like that. So, what I got to do is duplicate that and probably get a felt marker and mark that right there for the length. There's going to be a brush on the end of that, and we'll go into that later. It'll stick out about another 1/2 inch anyway, so I'm going to make a mark right there and then duplicate this bar. Okay, I got a couple of 5/8 rods clamped in my vise there. It's probably a better way to do this, but I made this one a little bit too short. It needs to be a little longer on both ends. So I'm going to make 4 more, just a little longer, and then trim them to size as needed. I'm making this out of 1/8 inch welding rod, brazing rod, 1/8 inch brazing rod. That's the cheapest way to go. If you buy an 1/8 inch rod, as 1/8 inch rod, it's a lot more expensive. Got a little brass ball I thread on there. Looks decorative. Okay, here's what we got to do now. That's a stainless steel thread that won't scratch those copper sectors or the disc. It doesn't put hardly any pressure on the disc, and it's a good conductor. It's stainless steel thread. Carlson Robotics sells it. Amazon sells it too, but you got to be careful and get the right one. That'll be on the parts list. Okay, need a good pair of scissors. These are terrible. You're going to have to get me a good pair. Here's how I do it. You'll have to find your own way maybe, but about 4 revolutions. That over the end of the rod, slide the shrink tubing over it. It'll take you a few tries to get it right. Pull that out like that, about a 1/2 inch exposed. And take a torch and shrink that shrink tubing. That stainless thread will burn a little bit, but it handles quite a bit of heat. Then you can trim that loop, trim it off, or just cut the loop. Leaves you a brush there. It's kind of wimpy, but that's what you want. It's about right. It's not very critical. You just don't want the disc hitting the end of the rod. Can you hear that? So we're making a charge. Cool. I think I'll take these off and put some washers in there to keep the disc centered, and then we'll work on the collectors and electrodes. Here's how you take discs out. Put the belt up on the pylon, up on the disc support column. This is something you have to do periodically to these machines anyway. Take the discs out and clean them. Put a couple of washers on each end. They can be metal or fiber. I got some fiber washers I'm going to use. Maybe too many. I think so. I'll just put one on each end. I think that'll be all right. It doesn't hurt it at all to have some slop in there. All right. We're charging. We're ready to make some lightning here pretty quick. This is a capacitor socket, and it's I just made a wood cup, and I put a washer in there, and I drilled a hole and mounted it. And the reason I didn't do it in the center is because then I could adjust this way and this way to make it line up with that. I mean, if I got that slightly the wrong distance, I could move this. See, it moves like that. That bolt is a conductor. It connects both capacitors together. So, instead of turning a wood socket like that, I came up with a different method of doing this. Okay, I found a place with all kinds of brass parts. They're a little bit expensive, but they're actually they're pretty reasonable. If you bought a piece of brass and tried to make that, it'd be really expensive. But that's going to be our capacitor socket. And that's basically a conductor. And it'll be mounted on the base of the Wimshurst right there. I'm going to drill and countersink that for a number 10 screw, countersink screw. Just grinding off where it kind of pushed that brass out. Okay, I don't want to mount this like that because I've got to tie onto the bolt with a wire and connect the two capacitors underneath, and it'll hit that leg. So I want it like this, make it 4 inches, inch and a half. Oh, you know what I'm going to have to do? I'm going to have to countersink that wood a little bit. There we go. Okay, now we got to take a piece of wire. It can be any wire. It could be a heavy coat hanger, or it can be this thin wire here. Thin wire is easy to deal with. Wrap it around that screw head on the bottom. I mean the threads on the bottom. Put a nut on it. That's the conductor between the two capacitors. On the other one, I used a piece of copper tubing. Any kind of conductor is fine. This is just the easiest way. I don't think this will be a loss, a sharp wire down here. I may end up redoing this if I don't. You know, you gotta be careful about the most critical area for round, for keeping everything round, is right here at the electrodes. Everything else is secondary, but this may be a problem. This edge on this capacitor socket might actually be a problem. We'll see. But I suspect it won't be. I found a source for, like I mentioned before, for brass parts. It's pretty reasonable. As is, these are probably okay. If you look real close there, it's got a chamfer on the edge. But I put them in the lathe and rounded the corners on them a little bit on the ones I'm going to use. You can do whatever you want. You could, that's 1/4-20. You could put a 1/4-20 bolt and chuck it in there, and then chuck it in your drill press and just file that round. But I suspect it'll be fine as is. But that's for looks or whatever. Next thing we're going to do is what I call a capacitor link. It's for just holding the capacitor and linking it to the electrode. I I'm going to use a little different parts. I'm not going to use these balls. These balls are hard to drill. And I'm going to utilize some of these parts. Drill and tap the sides of both those and make the link out of that. This is a pretty good way of centering something. When that straight edge is level, you're on center. I need 2 of these with through holes. Okay, this is why I made this capacitor cup, or if you want to call it that, holder, adjustable, because this is going to be threaded into that and threaded into one on this side. And it's going to be hard to get that exactly the right length. I might luck out and do it, but it's be cut right there. It's easy to make them both the same, but it's hard to make them exactly that right length. I got one through hole and one on here that's going to be a cap on the capacitor. And what we want is those to be parallel like that, but we want them real tight. We want these threads to bottom out in that hole there. If you got exposed threads like that, that's really bad. That'll be a loss in the machine. You'll get coronal discharge off of that, and it won't work very well. So I'm going to tighten that, put it in the vise, and hopefully turn it another half a turn where those threads are not exposed. I like it. Yep, see how far off I am? Now, I don't know if that post is exactly straight, but I can adjust this in and it lines up now. Okay, the next step is to make the electrode support. This will be about there, maybe about like that. Then there'll be some collectors here. And then this will screw on here. And a piece of steel rod about 3 inches long will screw into here and stop it from rotating. Now I'm going to have to grind a flat. First of all, I need to shorten those threads. I made them too long. But I'm going to have to grind a flat in there so that when I tighten this rod into it, it tightens against that flat. That way, if I need to, I can get it back apart. If I run a steel rod into those brass threads, I won't be able to take it apart. And the only reason you'd really want to take it apart is to polish the brass, because brass will tarnish. So we're going to take this off, shorten those threads, and grind a flat on them. Here's what I'm going to do. I'm going to make a Sharpie mark where I want to grind my flat. Okay, I decided to take a new approach here. Instead of using this on there, I'm going to use this one. And the reason I'm doing that is because this cannot rotate. And I want to Loctite it into that. But I want to be able to remove this, so I'm going to put a set screw in there that lines up with that. See, it only screws in that far. So I'll put a set screw right there, and that will screw into there, and I will Loctite that in there. That way I can get this off, and this won't rotate. Okay, I've got these drilled, the set screw hole, and this is the electrode support. And I'm going to Loctite this in there. Hopefully that Loctite holds. From my experience, it holds really well. So, okay, I've got a choice of electrodes here. Collectors. That's what I made to begin with. I didn't really like it, so I had these laser cut. And they're kind of expensive, but I like them better. So let's see, this thing is going to go on here like that. Capacitor go under that. And this will go on. Lock collar, rubber washer, collector, rubber washer, another lock collar. And then this locks on. Okay, these need to go even with the axle, approximately, disc axle. It's not super critical, but try to get them the same height. Lock the bottom lock collar there, shaft collar, whatever you want to call it. And then push down on the top one and lock it down. What that does, it creates, the rubber washers create resistance in there, and those stay put. That way when you want to take the disc out, you do like that, and you don't have to worry about damaging your disc. Those need to be about a ½ inch from the disc, or maybe a little closer. These here will be drilled out, so they slip over that, and they'll have nylon tip set screws in them, and they'll have a 1/4 inch rod going through them, and that's what will hold the electrodes. That's why this had to be Loctited in there, because we don't want this rotating. This is 1mm solder with flux in the middle. That's the way to do it. I've tried using thicker solder with separate flux, and it's difficult to deal with. With the 1mm, you can put it exactly where you need it. If you can hit the spot exactly where you need it. And that'll buff off nicely, or fairly nice. Okay, I got an idea here. Let's see if it works. Super important to chamfer all the hole edges. Okay, this is a piece of nylon, maybe 3/16, I can't remember exactly. This holds the rod in the connector. And then, it goes right there. A little plastic piece goes in here. I hope this works. I don't know if I got enough depth. Little nylon slug goes in here. Kind of hard to get it in there straight because it's excuse me, real thin this way. And I'm hoping this little nylon slug will do exactly like that. Oh yeah, that works great. I may have to shorten that set screw a little bit. But that's why I went with steel right here, because when you got brass on brass doing like that, it kind of, over a period of time, it galls and it'll lock up. Whereas brass on steel won't do that. Oh yeah, I like it. Now I just got to make one more connector like that. Okay, I got the other side made. But I'll have to do something about that set screw right there. I'll grind off the end of the set screw or put a little thinner plastic plug in there. But that's going to work good. Okay, these balls have an odd ball thread and it's specific to lamps. And when I first started making these machines, the 1/4-27 thread in this ball was readily available, but the 1/4-20 was not. But you can buy them in 1/4-20 now, and I highly recommend that. Dealing with the 1/4-27 is kind of silly. I'll probably end up having to put larger balls on there, but we'll see. Okay, I'm going to build some capacitors that look like that. But I'm going to rob some off the other machine right now, just to try this out. We still lack handles for the electrodes. And that's about it. Maybe some cleaning up and polishing. We're ready to give this thing a try. I'm going to have to explain a lot about this. Like the neutralizers, adjusting them increases the amperage. Oh. Well, that's the end of the fun for now. Watch right in there. You see that? That's where that capacitor just died. The spark went through the plastic. So we're going to have to work on the other capacitors now. Okay, these right here are like between $1 and $1.50 a piece. They call them Tom Collins glasses. I got a dozen of them. I don't remember what I paid for these. I got them on Amazon, but they don't work very good. I mean, they make a great capacitor, but you saw what happened. This right here is a decorative PVC fitting, kind of like what's on the these posts here. It's got foil on the outside and BBs on the inside. And on the bottom, it's got that foil wrapped around the bottom. That's so that it conducts with the little brass ring on the Wimshurst. That's not a very long spark, but there's probably some things we can do to increase that. Okay, I'm making a threaded insert for this PVC for an insulated handle on the Wimshurst machine for the electrode handles. PVC's inside diameter varies a little bit, but it's not a true size. This is 5/8. It's something under 5/8. Just going to turn this down till it fits. Well, it's a pretty good fit right there. I'm going to glue this in. So I need to give it something that the glue can grab, like a groove like that. And then I got to chamfer the edges, because believe it or not, inside that PVC pipe you will get discharge. Now I'm going to thread it. Okay, there's our inserts for these handles. They're rounded on each end to prevent discharge, and that groove hopefully is rounded enough. Inverted grooves don't discharge as much as something sticking out, but that'll hold the glue, and I'm going to glue that in these pipes with standard PVC cement. I've cleaned those good with acetone. And I'm going to do the inside of this pipe the same way, so the glue will stick good. I got a 1/4-20 bolt. I'm going to put that on, make it easier to apply the glue. On the other end, I basically ground a wood cork. Okay, let's see what this will do. Not too bad. That's 6 1/4 inch. I was hoping for more, but expecting about 6, 6.5. So that's not too bad. Let's discuss some of the particulars on this. First of all, before you ever touch the machine, discharge it. The capacitors hold a charge. See that? I fooled around a lot with this off camera, and there's several things that make a big difference on spark length. Number one, all your set screws got to be recessed into a hole. I ground off like this set screw I got in this tension arm, if you want to call it that. I ground it off a little bit so it would be recessed, and it made the spark longer. Capacitor size is a big one. Capacitors don't increase the voltage, which is what determines your spark length, but they increase the amperage. And if you've got some losses in your machine, which all machines do, you've got to have enough volume of electricity, which is amperage, to make up for the losses, and the larger capacitor will do that. And just to demonstrate, not only is this capacitor a little bigger physically, but this is thinner wall, which makes it much higher capacitance. If we go back to this capacitor, I'll show you what happens. Okay. It'll be the same length spark, which will be about 6 1/4, I think. Or it might be slightly shorter, we'll see. But listen to what it does. Also notice the strength of the spark. Sits there and spits and sputters. Every one of those little sputtering noises is a failed spark. So, the larger capacitors make a slightly longer spark, but more than anything, they make it more dependable. These don't fit these cups near as well, which I don't like, but when it's sitting on top of that brass thing, you don't really notice it. So, it's about 6 1/4, which is what we were getting before. This spark will be higher, more volume, and more consistent. Okay, let's talk about ball size. There's a lot of particulars on these machines that change the maximum spark length. This machine is DC. Okay, I've got it angled where it goes from the small ball to the big ball. The big ball is important. The bigger the better, but past 2 inches, the amount of gain you get in spark length is minimal. These are 3-inch balls, so they're plenty big, at least for this size machine. The small ball, on the other hand, plays a big part in spark length. Spark length and reliability. The small ball will make a shorter spark, smaller, but it depends on the machine power. I don't know if it'll spark here. Okay. That's about the same length right there. That's, if it'll spark, that's the same length. But it doesn't like to because it's got a small ball. So that just discharges the machine with the tape measure. There's a chance you get shocked by doing that. So let's go larger and see what happens. Basically, the larger the ball, the more resistance it will have to jumping. Think of it like holding back the spark and letting the capacitors reach full charge. But if it holds back too much, it won't jump. So there's a balance there. Now this one will probably work. It'll just be a shorter spark. That's actually working pretty good. That's kind of finicky. That might be the optimum ball size with the larger capacitors. I was doing all that testing with the small capacitors, and the next size smaller was actually optimum. So let's see what size spark we got right here. Oh yeah, that's 7-inch. That's a 1-inch ball versus a 7/8 inch ball. Yeah, that's good. Now, let's discuss polarity and voltage and amperage on the neutralizers. First of all, the position of these neutralizers determines if they're this way, the amperage increases. If they're this way, the voltage increases. So, there's an optimum position. You got to have enough current or volume of electricity to make the spark jump. The spark length is determined by voltage, but if you don't have enough amperage, it won't jump. So you got to find an optimum there, and I think we're pretty much, I played with it a little bit, and I think we're pretty much at optimum there. So, polarity. Polarity is, this is a DC machine, and this is the positive terminal with the small ball. And the reason I know that is because it won't jump the other way. That probably won't jump. You hear a lot of noise. Isn't that something? It will eventually jump if you get close enough. Look at there, you got, that's about half the distance, and it's still not jumping. Just a lot of noise. But if you go this way, no noise, and it jumps. Now you might say, look there, it's not jumping. There we go. I really do think that ball is slightly oversized. It's working good now though. Anyway, so why not have a small ball on one side and a big ball on the other and just leave it at that? That's great, except the machine is random charging. These discs are holding a charge in this polarity. Sometimes, if you let the machine sit for a long period of time, or something metal touches the disc, or a high humidity, you might find the polarity swaps. And you'll know it because it'll make this noise. You're like, okay, that's not right. So you change the polarity. Ah! Whew. Did you see that? I broke a rule. That's a good learning curve there. The machine was charged, and I had both hands on the electrodes. And that hurt. That hurt quite a bit. So, learning curve. Always, at least when the machine is charged, move one terminal at one time and hold on to the end of this electrode. Oh, that was probably good to see, but bad for me. So when you make an adjustment, one side, don't hang on to both sides, because then you become what the machine wants to spark to. Talk about safety a little bit. In this configuration, which I kind of like better, but this is more dangerous. I am really close to this ball right here. I got metal frames on, on my glasses. That may be actually a good thing. It'll hit the metal and transfer the shock to my head rather than going for my eyeball. But maintain a distance here. You don't want that spark jumping to you. Alternately, if you look at this machine, it's ambidextrous. I mean, it's symmetrical. It's basically the same, except I got the electrodes on this side and the capacitors on this side. There's no reason why I couldn't put the hand crank on this side, and then you can move the electrodes here. The only thing I don't like about that, and you could put longer handles on there, it'd probably be a good idea, but you're right next to that right there and the capacitor post when you're moving the electrodes. But it's probably safer like that. There's a long distance between the discharge ball and my head. So you can make it either way. With the crank on this side is probably safer. I may swap this one around. The neutralizer bars, the reason I made them like that, you know, the other machine was just a wire going across. I don't really like the looks of these too much. If this was brass, it would look much nicer. But the reason I made them like that is because they had to have that cutout here to make sure that the electrode bar didn't jump to the neutralizer. So you can make those however you want. I could have bent a wire in that shape and it would work just fine. I've done that in the past. That might be what you want to do. Just get creative on these things. One more thing, these collectors. The collectors, you can design them any way you want. I made these like this because I think they look cool, but more than anything, you can go like that, back them off, remove your neutralizer bars, take the belt off, and lift the discs out. Now, why would you want to take the discs out? Well, static electricity attracts dust, and dust gets all over the discs. It looks bad, but more than anything, it reduces the efficiency of your machine. By making the hubs out of Delrin, they're waterproof. So, although I try to avoid getting water inside the hub, but you can dry it, maybe blow it out with air. It's easy to run the disc under water with just dish soap and clean them off. But anyway, that about wraps it up for today. But there is going to be one more part. Let me tell you about that. There will be a part 5. This is part 4, and the machine's basically done. But in part 5, I plan on introducing a hardware kit and the plans, and I'll make them both available cheap, hopefully cheap. The hardware, if you went out and bought everything you needed in small quantities, ends up costing quite a bit. And I've bought everything on here in fairly large quantities, and it makes it considerably cheaper. So maybe I can put it all together and make a little bit of profit. I'll cover my costs for sure, and offer a kit, hardware kit. You'll have to provide the wood, the capacitors. You'll have to come up with your own capacitors. These capacitors, talk a little bit more about these capacitors. I found this Rubbermaid water bottle. That's what's on here right now. Made this top right here. It says Nescafe on the top. That was some instant coffee that my wife drinks. I don't know how she drinks that. These right here were Tom Collins drinks. I got copper foil on the outside. Any kind of foil on the outside would be fine. I put BBs inside because it's a lot easier than trying to get that foil to stick to the inside. All you have to do is wrap it around the bottom. So you can use just about any kind of jar. Only thing you got to be careful with, these are real thin and they work good for a while and then a spark blows through the bottom of it. So, but get creative. Anyway, that about wraps it up, and thanks for joining me, and be sure and subscribe. And be sure and stay tuned for part 5. Ring the bell, that way you'll be notified.